Okay, so you have to draw some galvanic cells for your homework in problems number 25 and 29. So what I'm going to do for you in this is show you how to draw a cell. There's some things that never change for any cell. We have to have one beaker and another beaker. We have to have metal bars. We have to have a wire connecting and the salt bridge. And we normally draw, when we have a choice, the anode here and the cathode here. Okay, I don't know that if they give you a picture that you should automatically assume the anode is on the left and the cathode is on the right. But when I draw it, I like to draw it this way. So the anode, the electrons always flow from the anode to the cathode. There's certain little phrases we can remember. We can remember an-ox, which means that this is going to be the oxidation side, and red cat, so the reduction will happen over here, and you can remember fat cat, which means from anode to cathode. That's how the electrons are going to flow. And you have to draw an arrow to show that they're going that way. So the electrons are going to go that way. The other thing that won't change is because this side's getting a pile up of electrons over here, the cations, the positive ions from the salt bridge, are going to migrate that way. So this is going to be like Na plus. We want to have positive ions going into here. So you can say positive cation. And then on this side, we're going to have anions flowing this way. So like Cl minus might flow that way. That makes sense because this solution would end up being very, very positive and might like not go. So we need to have the electrons going that way, some positive ions going over here to make sure that everything is still, electrically stable. And then on this side, if it's losing the electrons, then we need to have the anions coming in to make sure that it's also remaining neutral over here. So that's how the salt bridge is going to work. Now all we have left to do is figure out which one is the reduction and which one is the oxidation. But this is very easy because we have iron going from standard state. Let me check to make sure I wrote the equation right. We have iron going to iron plus 2, which would mean that it is losing electrons. So that's going to be the one that is oxidized. And ox happens over here. So that means that this bar is iron and that there's iron ions over here. Now, that Mn must be over here. MnO4 minus must also be in solution. You can tell when we balance this, because of the O, there will be H pluses also on this side in order for this reaction to go. The other one has no oxygen, so it's going to be balanced without any water or H plus. That means that this metal bar has to be made of something. We're going to use platinum. If you have a gas or some anions and cations, like some ions in solution, you have to use platinum as your other metal bar. So this is a sketch, and I'm not going to balance the equation, but if you did, you would get 2, 5, 16, 5, 2, and 8.